Hello guys, welcome to my channel, and here I always make videos on math and physics. That's where I go over concepts of mathematics and some examples to help you out. And please subscribe to the channel to watch all the videos. And in this video I'm gonna go over a special case of integration, and that's where we're gonna learn a rule like how to integrate integral that looks like this, so in which the numerator is a polynomial and the denominator is ax plus b raised to power n. Okay, so the rule is, so the first step is we're gonna look at the polynomial and see if the degree of the polynomial is greater than or less than this n. Okay, if the degree of the polynomial is less than n, then we're gonna rewrite this polynomial in terms of ax plus b, which is our denominator, and we can do that easily. With some practice you'll be able to do that easily. Okay, so I'm gonna go over a couple of examples too, just to show you how we can do that. Okay, and the second step is then we're gonna rewrite our integral that will look like this, like each term of the numerator divided by our denominator, and we're gonna find the integration of each part over here. Okay, so that's the one case. So second case is if the degree of the polynomial is greater than this n, then what we're gonna do, we're gonna divide our polynomial by the denominator, and we're gonna rewrite in this format. That's where we get quotient, the remainder, and our divisor. Okay, and then for this part over here we're gonna follow the same step 2, 3, and 4. Okay, one more time. If the degree of the polynomial is less than this n, we're gonna rewrite our polynomial in terms of ax plus b, which is our denominator, and gonna write each term separately and gonna integrate them. And if the degree of the polynomial is greater than n, we're gonna divide the polynomial by the denominator and gonna rewrite it. That will look like this, like our quotient, the remainder, and the divisor. Okay, and then afterward for the second part we're gonna use the same rule set, the rule 2, 3, and 3. Sorry, step 2, 3, and 4. Okay, let's do a couple of examples, and I'm gonna flip in between the rules and the examples so that you guys know what we are doing. Okay, so first example I got is x cubed over x plus 2 raised to power 4 dx. So you remember what was our first step. So first step said check the degree of the polynomial. Okay, so in this case degree of the polynomial is less than this n over here. N is 4 and degree is 3. So in this case we're gonna rewrite our polynomial in terms of ax plus b. Okay, let's do that. So if I look at it carefully, my ax plus b is x plus 2. A is 1 and b is 2. So I need to write my x in terms of x plus 2, and we can do that. It's not a big deal. Let's try to do that. So what should it look like? So let's say if I want to change this x to x plus 2, right? I added 2, but at the same time I need to subtract 2 over here too, right? And let's see if I put parentheses over here. See, we got our x plus 2, and then raised to power 3. I'm gonna divide it by x plus 2 raised to power 4 dx. Okay, now we're gonna use the formula, and the formula was a minus b cubed, right? This is my a and this is my b. So x plus 2 is my a and b 2 is my b, and formula says a minus b cubed is equal to a cube minus b cube minus 3ab into a plus b, right? And that can be written as a cube minus b cube minus 3a square b. So I'm going to distribute the multiplication, and minus 3a, and b multiplied by b gives me b square. Okay, so that's what we're gonna do over here now. So on the numerator, let's rewrite our numerator again. So a cube means a is x plus 2 cube minus b cube. B is my 2 and 2 cube is 8. 2 times 2 is 4 times 2 is 8. And then I got minus 3 a square, and a is again x plus 2 square, and b is 2. I'm gonna multiply it by 2 over here. Then we got minus 3 into a, which is x plus 2, and into b square. B is 2 and 2 square is multiplied by 4, right? And in the denominator I got x plus 2 raised to power 4 dx. Let's write it over here now. Okay, so that will give me x plus 2 cube, and 3 times 2 is 6, minus, I'm going to write them in order, 6 into x plus 2 square, and 4 times 3 is 12, minus 12 into x plus 2 minus 8. Okay, and divide it by x plus 2 raised to power 4. All right, let's do it over here. Next step. The next step is, what was the next step? Let's go back. See, we wrote our numerator in terms of denominator, which is x plus 2. See that? That was the whole goal over here. And next step is we're going to separate each term. Okay, so let's do that. So that can be written as, so first term is x plus 2 cube divided by x plus 2 raised to power 4. That gives me 1 over x plus 2. That's it. The second term is minus 6, and this is x plus 2 square and divided by x plus 2 raised to power 4. So 2 will cancel with 4, gives me 2 over here. So that'll give me 6 over x plus 2 raised to power 2 minus, then we got, let me see, I made a mistake. Let me fix that before we do any more damage. Okay, so according to formula, this is going to be minus sign. Sorry, this is minus, and this is going to be plus over here. And if that is plus, that is plus. So this is going to be plus over here, and this is going to be plus over here. Okay, so that's it. All right, so we got 6 over x plus 2 square, and this is going to be plus, and 12 over x plus 2, and in the denominator x plus 2 raised to power 4. So one power will cancel out with this one, so that'll give me x plus 2 raised to power 3. And the last one is just negative 8 and divide it by x plus 2 raised to power 4 dx. Right? Okay, now we're gonna find the integration of each term separately. So that means 1 over x plus 2 dx minus 6, and that can be written as x plus 2 raised to power minus 2, gonna take it to the numerator, plus 12, and x plus 2 raised to power negative 3, and minus 8, x plus 2 raised to power negative 4, and all of them have a dx, of course, and dx. And now we're going to use our integration formula, and that formula is going to be, gonna write it somewhere here. So that formula is ax plus b raised to power n. The integration of ax plus b raised to power n is equal to ax plus b raised to power n plus 1 over a into n plus 1. Okay, so we're going to use the formula over here, and the integration of 1 over x is log x, and over here it's x plus 2, so we got log of absolute value of x plus 2. So that's for 1 over x, and in this case we got negative 6, which is my constant, and we're going to write the integration of this part, so which is ax plus b and x plus 2 in our case, and see n plus 1, and n is negative 2 plus 1, and divide it by a in our case is 1 over here into n plus 1, so which is negative 2 plus 1 multiplied by 1. Okay, same thing over here, 12, this term over here x plus 2, and whatever is the n we're gonna add 1 and divide it by a is 1 into this n plus 1, which is negative 3 plus 1. All right, and then we got negative 8 over here, and again multiplication, and this gives me x plus 2 negative 4 plus 1, negative 4 plus 1, and divide it by 1 times negative 4 plus 1 plus the constant of integration. So I'm gonna write the formula on the side. Okay, so let's simplify them. So this gives me log of absolute value of x plus 2, and negative 2 times 1 is negative 1, and negative 1 multiplied by 6 over here makes it positive 6, and x plus 2 raised to power negative 1, which we can write in the denominator, plus 2 as a positive. Okay, then we got negative 3 plus 1 gives me negative 2, and gonna divide it by 12 gives me negative 6 over, and x plus 2 raised to power negative 3 plus 1 is an x plus 2 raised to power negative 2, and that can be written as in the denominator with positive power. Okay, and then we got negative 4 plus 1 gives me negative 3, and this is a negative and this is a negative, becomes positive, and we got 8 over 3, and numerator gives me x plus 2 raised to power negative 3, which can be written in the denominator with a positive 3 power. All right, so you see we can solve them, just take some practice and some patience. With the practice you can go more faster, you know. So again, the rule was, we saw if the polynomial's degree is less or greater. If it's less, we're going to rewrite our polynomial in terms of denominator as we did over here. Okay, let's do one more example. So next example is x cubed divided by x plus 1 square. And again, what was the first step? First step is check if the degree of the polynomial is greater than or less than n. So in this case, the degree of the polynomial is greater than n over here. So what we're gonna do in this case? So we need to divide our polynomial by x plus 1 square. So which is this scenario over here. If the degree of the polynomial is greater than n, divide the polynomial by the denominator, and I'm gonna write it in terms of quotient, remainder, and divisor. Let's do that. Okay, so what will happen in that case? So we'll get x cube over here. Let's do the division. X cube over here, and we're gonna divide it by x plus 1 square, which is basically x square plus 2x plus 1. Okay, and I'm gonna multiply by x. So x times x is x cube, and 2x square, x plus 1 is x. Then we're gonna divide, we subtract. I always change sign when I subtract. So cancel out. So this gives me negative 2x square and a negative x. And then if I multiply by negative 2, so negative 2 times x square gives me negative 2x square. 2 times 2 is 4, so negative 4x. Negative 2 times 1 is negative 2. I'm gonna subtract again. I always change sign whenever we subtract, so cancel out. So this gives me 3x, this gives me minus 2, and that's where we're gonna stop. Okay, so we don't have any term in x square, so this is our divisor. So this is my remainder, this is my quotient, and this is my divisor. So let's go back, and so we're gonna write quotient plus, so we're gonna write quotient plus a remainder over divisor. So let's do that over here. So quotient is x minus 2 plus my remainder, which is 3x minus 2, and my divisor is this, which is basically x plus 1 square. So x plus 1 square over here. Okay, so now if you remember, let's go back to the rule again. So we're gonna change this polynomial over a denominator. We're gonna change the polynomial in terms of the denominator as we did in our last example. So this is the step, and we're gonna go accordingly. So let's do that. So we are not going to say anything to these x minus 2 because we can find their integral easily. Yes, sir. Keep them there as it is. We're gonna play with this number over here. So in the denominator we got x plus 1. Okay, so how we can change this numerator into x plus 1 format? Okay, sorry, this is going to be positive 2, not negative. 3x plus 2, this is positive 2. All right, so x plus 1, and how we can make, if I add 1 over here, okay, let's do it. 3x, if I add 1 over here, this will become 3, and I can take 3 out, and this will give me x plus 1. All right, if I added 1, I'm going to subtract 1 and 2 to make it equal. Okay, so x plus 1 square, you'll see what I'm talking about in a second. Okay, so this is going to be x minus 2 plus, so 3x, 2 plus 1 is 3, minus 1 over x plus 1 square. This is equal to integration of x minus 2 plus, so if I take 3 common from these two numbers, if I take 3 common, I'm left with x plus 1. So x plus 1, okay, minus 1 over x plus 1 square dx. Okay, I think we are getting there where we want to be. So that means this is equal to integration of x minus 2. We're gonna go to the next step, which is write each term separately, divide them by the denominator. That's what we are going to do over here. So x at is as it is, negative 2 as it is, plus 3 into x plus 1 divided by x plus 1 square. This is x, oh my god, how many times I'm gonna make it look like an x. There you go. And then minus 1 over x plus 2 square. Right, and now we're gonna do the derivatives. Okay, so let's write them I'm gonna do it over here. Let's do it. Integration of x dx. Integration, I'm gonna take 2 out, just dx plus 3. Integration of x plus 1 will cancel 1 of the power over here. That'll give me x plus 1 minus integration of, I'm gonna take it to the numerator, x plus 2 raised to power negative 2 dx. Okay, and we're gonna use the same formula again. What was that? So if you remember, the integration of ax plus b raised to power n is equal to ax plus b n plus 1 over a into n plus 1. So that's the formula we're gonna use over here. Okay, so let's write down our answer. So integration of, I think you all know how to find the integration of just x, which is raised, add the power 1 plus 1, so that give me x squared over 2, and this is just 2x over here, and this is 1 over x, so this is going to be 3, which is log of x plus 1, and this part over here will give me which is x plus keep making minor mistakes. So this is not a 2, look over here, it's 1. Okay, my bad. X plus 1. Okay, all right, so the integration of ax plus b raised to power n is equal to ax plus b minus 2 n plus 1, so 1 over a is 1 over here into n plus 1, which is negative 2 plus 1. Okay, and when we're gonna solve it, let's rewrite it, x squared over 2 minus 2x plus 3 log of absolute value of x plus 1, and the last part will give me, so negative 2 plus 1 is x plus 1 raised to power negative 1, and negative 2 plus 1 gives me negative 1, so negative 1 multiplied with this negative gives me positive, and this x plus 1 raised to power negative 1 can be written as 1 over x plus 1 raised to power positive 1. Alright, so that's how we can integrate these kind of integrals. That's where you got a polynomial in the numerator, and the polynomial is divided by ax plus b raised to power n. Okay, thanks for watching the videos, guys. Please do a couple of more examples, that way you will be good to go. And please share with your friends and subscribe to the channel to watch more videos on math and physics. Thank you. Have a good day. Bye bye.